afternoon, everybody, and welcome to this lightning talk about contractual data assets. So before we begin, there's a couple of things that I would like to mention. So one is this is a pattern for implementing data quality. Now, the concept of data contracts go beyond just data quality. It encompasses a lot of features about data sets. But for the purposes of this session, we'll be focusing primarily on data quality and how to codify expectations for your data sets through a prescribed framework. Now, second, this pattern was introduced at Abercrombie to solve problems that we have faced in-house over the years. So I've been with Abercrombie for about 10 years, and we've had a lot of challenges with data quality. So we've kind of aggregated all those, we've kind of consolidated the problems that we've been facing, and we work towards building a solution to addressing these problems. So it is possible that your shop is ahead of the curve. So if that is the case, please bear with me. All right, it's about me. So I have been a data engineer for the last 15 years, and I switched over to the operations side of the house about 3-ish years ago, and but still I focus on the data side of operations. So the agenda, we're going to be starting off with the problem statement, as in what is the issue that we face, what is the current state of affairs from a data and the quality perspective. And then I'm going to go through a technology agnostic way of solving the problem, or an idea that I will be sharing with you. And then I will be showing you an example of a concretion, as in how to implement the idea. All right, so this slide pretty much shows what's going on today. So we start off all the way to the left, we have product inception. So this is where our business partners come and request new data sets, or they just want to perform analysis on new measures on the data. So they come and request for new data sets, and that's the product inception phase. And once all the monies in the budget have been allocated, we go into the dev test cycle. And that is where, in the case of large initiatives, we have dedicated QA teams performing the tests. So most of that testing is manual, and they write all these tests and export data in Excel and then compare things. It's a very janky way of performing tests, but that's pretty much what how things are carried out today. And once everything looks good, we go into productionizing the pipeline and the associated data sets that the pipelines produce. So after production comes the bigger problem, where the business users, they see issues with the data sets, and then they reach out to the engineering teams for the fix, and then it goes into the fix cycle, where you build a patch, and then you test out the fix, and then it's sent back to production. So there's a vicious cycle going on over here, where things that are being pushed to production, business is now losing confidence in the data because they are not sure if the data that they're working with is up to the mark. So just some audience engagement. How many of you can relate to this slide? Hands in the air, please. Well, I see almost everyone's hand up in the air, which in a way makes me happy, because this is not something isolated to Abercrombie. This is pretty much across the board. And also, it is rather concerning because this is everywhere and not just isolated to a few firms. So this cuts across the board. All right, to summarize, we have manual tests, so tests written and executed in Excel sheets. There's no concept of regression testing, because once the product has been shipped to production and the product undergoes evolution, there is no way of going back and ensuring that the data that is in those data sets are up to the mark, because there is a possibility that changes have introduced errors that we are not aware of. And now comes the problem of tribal knowledge, where the knowledge of the data and the processes are pretty much isolated to small groups of individuals. I'm sure you have in your shops, there might be one or two folks who know everything about the data, and there's a lot of dependency on these individuals, right? So one, they end up becoming the bottleneck. Even though they do come and resolve issues, they end up becoming the bottleneck themselves. And God forbid they win the lottery and they decide to move on. It makes operations that much more challenging. And then you have the cost implications, because now you got to dedicate resources to fixing the issues with the data sets. So it becomes a problem with resources as well. Now you got to allocate a lot of resources just to fixing the issues with the data. All right, so let's move on to the solution that we have proposed in-house that I'm going to share with you. All right, so what we wanted to build is a unified data quality platform. And it starts off with, so on the very top, you can see the different stakeholders here. So we would like to involve the business stakeholders, data governance, and the engineering teams themselves to define expectations for the data. Now, one of the critical shift in philosophies that we are embracing as part of the data modernization initiative is that the data assets are owned by the domains, not by the engineering teams. We are trying to shift that responsibility or encourage more participation of the domain owners in the very data sets that their domains produce. And so the stakeholders go ahead and define the contracts or the expectations for the data, and the platform should be able to launch the checks or initiate the checks based on the expectations. And what we are also doing is we want to elevate data quality or issues with data quality as a first-class citizen from an incident management perspective. As in, well, data quality for the most part is a silent issue. It happens, the systems all show that things are looking good, but the quality issues, they lurk under the surface. So what we are doing is, as part of the incident management, we would like to integrate the platform with our incident management system, which then goes to a dedicated command center and then goes to data operations on-call gets paged, and they start triaging the incidents as and when they receive them. And on top of that, we would like to shift left from a software development lifecycle perspective. So we are embedding the expectations in the CI/CD pipelines and also during production. So we are trying to push checks all the way upstream as much as possible. Now I'll be covering a little bit more about the proactiveness aspect of tests and how we are trying to achieve that. So this is an overview of, or this is the big picture overview of what we are trying to achieve. So we have here the primary objectives: empowered governance. So we don't want our data governance team to be quote unquote paper tigers. We want them to contribute directly to operations. So when they write expectations for data sets, they are injected directly into production operations. They are not a recommendation, rather they are an enforceable mandate. Next, we have data observability. So till date, we didn't have a way of figuring out how healthy a data set is, or if the data set is up to the mark for consumption by business. So data observability is the next objective. And then, like I mentioned, increased participation of the different stakeholders. So since folks on the business side are not necessarily technical, we want to enable non-technical users to participate in data quality. And then finally, implementing engineering discipline. So I don't think I'm making a controversial statement when I say conventional software engineering is way ahead of the curve when it comes to data engineering, and specifically from the perspective of testing, unit testing. And they got all the fancy stuff. They got unit testing, they got load testing, integration testing, everything. But on the data side of the house, that even if that is implemented, it's quite a challenge to make sure that that data quality evolves as the data products evolve. All right. So with this as the North Star, we now started going into vendor selection. So it's not that, we were sort of charmed by the product salespeople, which is why we decided to buy the product. No, so we had the idea first, and then we created a vendor selection scorecard. So these are some of the aspects that we were looking for: user friendliness, connectivity. So we have different technologies which are used for analytics. So we need to observe the data sets that are created on the different platforms. And we have automation patterns. We would like to inject tests in. So we have the CI/CD, the ELT pipelines, and the orchestration pipelines themselves. And then we have incident management, good integration with our incident management platform. And then no data shuffling. I think this is a requirement for a lot of firms who have requirements that the data has to reside within the VPC and the data should not egress. Besides, your cloud operation costs can skyrocket if your egress is not in check. And then finally, identity access management and security. So integration with our Active Directory, Azure Active Directory, using SAML and MFA, and also the network security, that's the VPC deployments. All right. So we have defined what are the expectations, or rather, we have defined the North Star for this solution. Then we went into defining what are the minimum expectations we need to certify a data set, or call a data set certified for consumption by business. So let's take a look. So we start off with freshness. So some of the reports that we send out to our leadership is at a specific time. So we got to make sure that the data sets, the underlying data sets that power those reports, have to meet the SLOs that are defined. So that is the freshness. So has the data set been refreshed by a certain time? So that's the first one. Second one, uniqueness. Now in your dimensional data, if you have duplicates, that can lead to a cascading effect across the board in your data warehouse or your data lake. Because dimensional data is a very critical data set, and any analysis that's performed on that can have significant deviations if there are duplicates. Then comes volume. Now a lot of the data quality issues are silent failures, but this one is especially notorious because, for example, if a data set, you expect 1 million records every day, and then one fine day there's like 1,000 records that showed up. Now again, the system says everything is green, there's no issues. But that is a definite issue because somewhere in the pipeline, somewhere in the multiple hops that the data has taken to reach the final destination, something has gone wrong. So that's the volume aspect of it. And then we have the nulls, which is pretty self-explanatory. So if there are nulls in columns that should not have nulls, then that should be flagged. And then referential integrity. So this is where values in a column should be part of a dimensional data, as in things that should not be in that column, or only the right data should be in the column. And then we have schema. Now, in our case, we have strict schema definitions, but I understand a lot of shops have automatic schema evolution. So if an error is introduced inadvertently and that changes the schema of the data set, then that should be surfaced as soon as possible. And then we have custom expectations. So this goes one layer deeper. So this requires a lot more domain knowledge. So these are not, straightforward test cases. So expectations that require a lot of domain knowledge, that require custom logic to be implemented, or regression tests. For example, if the sales for a region has to be in the ballpark of X million dollars for a specific quarter, and in your data shops, you will face a situation where you have to refresh data sets because you're trying to retroactively implement a change. Now, in the course of refreshing a data set, you got to make sure that everything else is still the same and only that change is what's being affected. So we are looking to implement regression tests as well. And then SQL-based checks, since in our world, declarative is better than imperative, and SQL being a declarative way of expressing your logic, we were looking for SQL-based checks to be incorporated as part of the pipeline. All right. So the next one that we are looking for is proactiveness from a data quality perspective. So, like I mentioned, your data will go through multiple hops to reach the destination. So where do we want to execute the checks? Do we want to do it at the service domain boundary? For example, the supply chain data assets on Databricks curated layer is considered a data set that exists on the service domain boundary. So we're starting off over there because that is pretty critical, because from there, the data set is used for reporting purposes. So we start off over there and we move up the data supply chain all the way to the source. So that is a shift left from a data supply chain perspective. And then point of materialization, how proactively do you want to monitor? So all of you are, I assume, are Databricks customers. You guys are here, so you use Spark. And Spark data frames are objects in memory. They have not been persisted to disk. So is it possible to run checks directly on the data frames as opposed to data that's persisted on the lake? Right? So that is the highest level of proactivity that we are trying to achieve. And the other point of materialization is right after you write to your lake, you can asynchronously kick off a process that verifies the data that has been materialized. And then the last one is after batch. And from a software development perspective, we are trying to implement test-driven development and embedding tests in CI/CD pipelines. All right, so after we took all those into consideration and we had the vendor selection, we went through a rather extensive vendor selection process and we ended up with the SOTA platform. So this is pretty much just a screenshot of what SOTA is. So it is a way to declaratively write expectations for your data sets. So the checks are written in a human-readable YAML format, and since we want non-technical users to participate, so this is the UI that lets you write checks against data sets, and that's an example of creating a numeric check on the store's data set. So we are writing the max length of region number should not be greater than 3, and it shows what alerting should be in place for those data sets. Now, SOTA has an extensive checks language. Well, I'm already almost out of time, so I won't be able to cover all that, but you can go take a look at this. So they have an open source version, SOTA Data, SOTA Source. You can go to their docs, and they are available at booth number 16, so you can stop by and take a look at what they have to offer. And this is an end-to-end architecture. It's very simplified. The data stakeholders, they author the contracts and the checks, and scan, which is the unit of orchestration, then kicks off the checks using the SODA agent, which is either self-hosted if you want data to be within your VPC, or a SODA hosted agent, which connects to the Databricks serverless SQL endpoint. You would rather go with serverless to reduce the time for the compute to spin up and initialize and all the good stuff. And that SODA translates YAML into the SQL dialect of choice. So in this case, this is Databricks SQL. If you're using any other solution, it will translate it to that system's SQL dialect and will run the checks. And what is returned back to the platform is metadata. Also, it can sample the records that do not meet your criteria. But if you have PII concerns, you can flip a switch on SODA platform and say you don't want any data to be shuffled back to the platform. So you have that security built in as well. Right, so the inspiration, we have modeled this after the professional sports operating model. So on the left is the sports org, and on the right is what we have. So league governance, so that is where your Roger Goodells, your Adam Silvers all operate. On our side, it's data governance and stewardship. The teams, they're the franchisees. On our side are the domains, and the athletes, with, of course, they are the engineers on our side. You score a touchdown, and engineers close the Jira cards, right? They're both the same thing. We all know that. All right, so that brings an end to this session. Any questions? All right, thank you.